For this assignment, I decided to try and explain the basics of how a common household item, the blender, works. But to do this, we first must deconstruct the blender. Blenders are relatively basic machines consisting of 5 parts. First is the housing, which is the base of the blender and contains an electric motor which is generally fan-cooled. The housing is also home to the speed controls should the blender have any. It is heavy in weight compared to the rest of the machine, which helps keep the appliance from moving or falling while working. Second is the blade, which is attached to the housing and spins when the motor is running. The blade is usually made up of multiple pieces of metal on multiple planes. This allows for more contact of the materials with the blade while being blended, and it also helps in the actual mechanics of the blending, which I will explain later. The blade sits inside the gasket, which is there to help prevent leakages. Next is the jar, which is the large cup-like feature of the blender where all the components needing to be blended are added. Finally comes the lid, which is the piece that is placed on top of the jar to prevent any spillages during the blending. Last year in another class, I actually had to do a group project where we deconstructed a blender. So as I do not currently have a blender that I can break apart for you, here are some images from last year's project so that you can see inside the housing of the blender to its motor. Blenders are an appliance that you have to plug into a wall socket. So the electricity will react with the metal prongs of the plug and run along the plug's wiring until it reaches the base of the blender. Here you can see where that long white cable that was attached to the plug runs through to the base of the blender. Inside the base of the blender is where the wiring inside the plastic shell of the cable come in contact with a metal plate. This plate is also in contact with 2 other wires that are inside the base of the blender that run through to the motor of the blender. Here is the motor of the blender inside the shell of the housing. Remember the previous image, the motor is a solenoid, which means that the coil wiring is what allows it to spin. As it is attached to the blades, this is what allows the blades to spin and is where the electrical energy finally gets converted into work. Obviously, there are many different kinds of blenders that all have different power strengths and different features, so an exact power usage is hard to find. However, after doing some online investigation, I found that a common average blending power is about 300 watts. However, if we go back to how exactly a blender works, as I said, the motor will begin to spin when the electricity reaches it. As the motor is attached to the multiplanar blades, they will spin as well. This creates a sort of vortex inside the jar. The vortex creates a vacuum at the center which pulls all the newly added food to the center and down toward the blades, where they then become liquefied. This liquid is then forced up and out the sides of the blender. This pattern will continue until everything is evenly mixed, giving you that perfect morning smoothie.